Well, hello there. We're going to look at 2017 BC6 today, aka the series problem. As you know, every test is going to have a series question. Now this year, because of the wacky spring that we have, the College Board has changed the topics a little bit for the AP exam, but the series question is still going to be the series question, and we should know how to do all of it. So don't you worry about that. For now, let's look at 2017 BC6. We can do this. F of 0 is 0. F prime of 0 is 1. Okay? Show that the first four non-zero terms of the Maclaurin series are the following. Okay, we can handle that. Let's get the other two derivatives. If f prime of 0 is 1, I'm going to follow the guideline here. So that's going to be the double prime would be -1 plus, would be 1 plus 1. So then that's -1 times the previous derivative at 0. So that's going to be -1 times 1 or -1. F triple prime of 0 will be the one less, so that's going to be -2 times the previous derivative, which is -1, so that will be 2. And we'll go ahead and do the fourth derivative at 0, which will be the opposite of the third derivative, or the opposite of 3 times the third derivative, so that's -6. And so we know that the general form for the Maclaurin series is going to be f of 0 plus f prime of 0x plus f double prime at 0 over 2 factorial x squared plus f prime of 0 over 3 factorial x cubed plus the fourth derivative at 0 over 4 factorial x to the fourth. Okay, we have that memorized. We know all that. Let's fill it in. So that's going to be 0. That's going to be 1x. This is going to be -1, 2 factorial x squared. Again, we're not simplifying in our p-brains. We're just writing stuff down first. No simplification, because we want to make sure that we get the points necessary. Okay, now the question is this the same thing as we were given there? And it sure looks like it. X minus 1/2 x squared plus 2 over 6, 1/3 x cubed minus 6 over 24, which would be a fourth, x to the fourth. Okay, so there's part A, done, check. What about, and write the general term of the Maclaurin series. Okay, so what are we doing here? What's the general term? Well, plus ... plus what? Well, what have we done? Look at over here. What's our general formula for the derivative? That's it. So what's f to the nth of 0? It's going to be -1 n plus 1 x to the n over n. Okay, so that's all we got that from is what was given in the problem, right? So that's how we're doing all of this, okay? So that's how this works, right? 2, 3, 4, pretty straightforward. There's part A. Let's go to part B. Part B says, determine whether the Maclaurin series converges absolutely, conditionally, or diverges at 1. Okay, well, essentially they're saying, what's going on here? All right, so let's look at 1. So this would be 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6. I think we can name that too, can't we? I told you that story before, didn't I? Okay, now this converges. But what about the absolute values? So what about -1? So that would be -1 minus 1/2. 1/3 times -1 cubed minus cubed. 1/4 times -1, 1/4 minus 4. Uh-oh, this is the harmonic series, but it's not alternating. And what happens when the harmonic series does not alternate? It diverges. So let's write here x equals 1, x equals -1. Because these are not the same, we have a conditional convergence. If they were the same, converge absolutely. If they were the same and they both diverge, then we'd say diverge. But if they're different, we say converges conditionally. Okay, so we're conditional. Boom. All right, now let's go. Is that it we ought to do there? Yep, now let's go to C. First four non-zero terms and the general term of the integral of f. Okay, so we're going to leave that there. I'm going to slide this screen over. Okay, so let's do part C. Let's take the integral here. So we have the integral from 0 to x of f of t dt. Okay, now, what are we going to do? We're going to take that function that we had from part A, right? So let's go back to part A, right? We have t minus t squared over 2 plus t cubed over 3 minus t4 over 4. How many terms do we have to do here again? First 4, okay? Plus our general term. Now, the general term, -1 n plus 1 t to the n over n, and then we'll say dt. Okay, well, let's rock this out. We can handle this. Let's integrate. All right, so again, this will be t squared over 2 minus t cubed over 3 times 2 plus t4 over 4 times 3 minus t5 over 5 times 4. How about the general term? Well, the -1 to the n plus 1 and the n, they're going to stay. And what is the integral of t to the n? That's t to the n plus 1 over n plus 1. Oh my gosh, plus dot, dot, dot. I'm going to squeeze this in here, evaluates 0 to x. So in other words, the key here for students is the -1 to the n plus 1 over n, that's just a constant. Stays the same. But then t to the n becomes t to the n plus 1 over n plus 1. Well, at 0, all those terms go to 0, so we'll just evaluate this at x. So then our answer here is going to be x squared over 2 minus x cubed over 6 plus x to the 4th over 12 minus x to the 5th over 20. Simplify that, plus dot, 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 -1 to the n plus 1 over n times n plus 1 times x to the n plus 1. Okay, not so bad. Okay, we're almost done here now. Part D. Here we go. Let p sub n of 1/2 represent the nth degree Taylor evaluated at 1/2. Use the alternating series error bound to show that this term has to be less than 1 over 500. What's the alternating series error bound? Series alternates, terms get smaller, go to 0. Therefore, the error will be less than the next term, right? Let's rock it out. Okay? Here we go. Okay? So, we have to use they say the 4th derivative, right? So we got to get to the 5th one. So let's just check and make sure that this is working here. Okay, let's go 1/2 squared over 2 minus 1/2 cubed over 6. What do you guys think? Do you think that's getting smaller? I think it sure is. Do you think it's going to 0? Heck yeah. Right? Now, we want to know about the error associated with the 4th degree. It's going to be less than, what's the next term? It's 1/2 to the 5th over 20. So the absolute value of the error will be less than or equal to the absolute value of 1 over 32 times 20. What's that? 1 over 640? And on my planet, that is indeed less than 1 over 500. Once again, we win. So let's adjust that screen just a little bit so you can see the bottom there. We went through that last part kind of quickly, but it's the alternating series error bound. Now in this one, we were not given anything in the we were not given the hypothesis of the alternating series error bound like we sometimes are. So let's go ahead and say alternating terms decreasing toward 0. Therefore, the error will be less than that. Does that make sense to you guys? So we have to go ahead and state the hypothesis. As you know, in some of these problems, we're already told the hypothesis, so we can just make the conclusion right away. That, my friends, is 2017 BC6 in one take. See you in the next class.